Hey everyone, AliExpress tempted me again. This is an arbitrary waveform signal generator. I always wanted one for my lab, to run various experiments, test circuits and devices. This one is extremely cheap considering what it claims. I got it for $37 free shipping. According to the listing, it is 24 MHz dual channel 12-bit resolution and 250 megasamples per second. Let's see what we really get for the price. And of course, right away there is a problem. Only 2 pins on the power inlet, no ground wire. I'll show you why that matters in a moment. Let's power it. Let's measure voltage between actual ground and what's supposed to be ground. Multimeter shows 82 volts AC. That's already bad, but let's take a look at it on the oscilloscope to understand better. The scope shows voltage swings from plus 160 volts to minus 160 volts, and that is on the ground side of the BNC connector. Looks dangerous, but it will not electrocute you because the current is very low, but it surely can damage sensitive electrical devices, so grounding is needed. This isn't a unique problem, others have found the same. Luckily the fix is simple, add a proper earth ground wire. Let's open the device. The inlet they used is C8 type, which doesn't even support grounding. I'll replace it with a C14 inlet I salvaged from an old PC power supply. Let's remove C8 inlet. After making the cutout bigger, C14 inlet fits well. All that's needed is just to drill mounting holes. Now I just plug the disconnected cable during the soldering, so pins will not bend. I decided to solder a thick wire to the ground pin, to which later I will solder other wires. After that I just solder power wires. Now let's just insulate everything with heat shrink tubing and continue. Now we just install new inlet and mount it with screws. Now I just solder wires to the ground of each BNC connector. Now the device will have the shortest path to the ground from each BNC connector. There is actually a ground pad on the internal power supply, it just wasn't connected to anything. I soldered a wire to it too. And let's not forget about BNCs on the back of the generator. Now let's connect all of the ground wires together. A bit of soldering and we are good to go. And the final touches with the heat shrink tubing. Now everything looks neat and makes sense. Let's measure it again. 0 volts between ground on the BNC and the real ground. Exactly as it should be. The next mod isn't strictly necessary, but I highly recommend it. I'm going to fully isolate the USB connection. Cool part about this mod that it is easy, feels like this device was made for this modification. That is because USB to UART converter is on a separate board, so all communication with the main board is done via UART. That means I don't need a complicated USB isolator, I can just isolate the UART lines. I'm using a dual channel digital isolator module, claimed isolation up to 3.75 kV RMS. Good enough. Wiring is simple, cut the TX, RX, VCC and GND lines, and then solder the isolator in between. TX to the input of the isolator and the output to the RX. Same for the other line, but in the different direction. Classical UART communication, nothing fancy here. Now on the device side I measure 5.17 volts, but on the USB side only 4.13 volts. That's wrong, but expected. The reason is because VCC pin on the USB side wasn't connected to USB's 5 volts at all, it was only leaking voltage through TX-RX lines. That actually made sense before this modification, current should not flow from the USB and power the device. The device should only receive its power from the internal power supply. There is an easy fix, we just need to add a jumper wire on the USB to UART board, so the UART insulator would get a proper 5 volts from both sides. Surprisingly, the communication worked even without the jumper wire, but let's make it right. After that we have clean 5 volts on both sides. Everything is isolated and powered correctly. Now let's add some heat shrink tubing and we are done. Now the device is properly grounded and USB isolated. USB communication works, so let's reassemble everything and give it a proper test. Before running full test, I want to show you how to calibrate the generator's frequency. Hold down the parameter button together with the left button while powering on. The device will output a 10 kHz signal. To calibrate, compare this output with a known reference. In my case, I'm using DIY GPSDO. With both the signal generator and GPSDO connected to the oscilloscope, you can observe phase drift, because the generator isn't exactly at 10 kHz. Adjust it until there is no drift, or as little drift as possible. Then power off and calibration is stored. Now let's run some tests. Change the frequency and try different waveforms. Let's hook it to tinySA spectrum analyzer to measure harmonic content. Let's start with 1 MHz as fundamental frequency and test harmonics. The second harmonic is at -46 dBc, not great, not terrible. On the scope the sine wave still looks clean, of course. If we increase the amplitude to the maximum of 20 volts peak to peak, the third harmonic dominates at around -21 dBc. Even on the scope it looks a bit distorted. Reducing the amplitude lowers the harmonics significantly. Let's try 5 MHz. The second and third harmonic around -43 dBc, so it's getting worse with the frequency increase. With amplitude increase it gets even worse. Let's try something much higher. At 15 MHz fundamental, the second harmonic at -25 dBc right away. If we increase the amplitude to the maximum, the sine wave looks visibly distorted. We don't need a spectrum analyzer to see that is bad. The second harmonic is at terrible -15 dBc. So the conclusion is simple. Keep both frequency and amplitude low, and the distortion is tolerable. Push it high and the output gets messy fast. Of course, this isn't professional grade equipment, but for $37 after some grounding and USB isolation mods, it's now safe and useful signal source for my lab. It's USB controllable, supports custom waveforms and can even measure frequency. So overall, I'm happy to have this new toy on my bench. What do you think? Is it worth the price? Would this satisfy your needs in a signal generator? Let me know in the comments below. And as always, thanks for watching.